Question 3. A car will skid to a halt at a uniform rate of negative 9.4 meter per second square. So again, we try to draw the velocity time graph. So again, we don't know what's the initial speed, so let's just label this as v1. We don't know at what time did the car come to a complete stop, so let's just label this as t1 again. Okay, but what we do know is that this area is 30 units square because it's 30 meters, right? The skid marks are measured to be 30 meters long, and we know that the gradient of the velocity time graph is minus 9.4. That's the deceleration. So again, we know that the area under the graph is the total distance traveled before the car comes to a stop. So 30 is equals to half times t1 times v1, just as in the previous question. Okay, so this is equation 1. Let's try to find another equation so that equation 1 and that equation can be solved simultaneously. We also know that minus 9.4 is the gradient, which is equals to v1 minus 0 over 0 minus t1. So v1 is equals to 9.4 t1. For this question, we are just going to rearrange it so that t1 is equals to v1 over 9.4. Let's just label this as equation 2. Okay, if you substitute equation 2 into equation 1, you will get 30 equals to half times. For this one, you're supposed to find the velocity, so you want to substitute the t away. That's why I rearranged equation 2 to make t1 the subject. Okay, so this is half times v1 over 9.4 times v1. Rearranging, we have 60 equals to v1 square over 9.4. So v1 square is equals to 60 times 9.4. v1 is equals to 23.748 meter per second. So you can round this off to 3 significant figures. So this is just 23.7 meter per second. Okay, so this is the initial speed of the car just before the driver slammed the brake.